See if you guys remember how to solve that. Now, obviously, a lot of people can look at that and kind of just figure out, all right, I know what the answer is. Because the algebra problem itself really isn't all that difficult. But the idea behind working with the proof part of it comes in such a way that it forces you to write down your steps. What exactly are you doing for each and every single one of these as you go through? For example, when we start with this one, what's the very first thing you are going to do?
Add 1.
Add the 1, okay? Come on, guys. I'm adding 1 to both sides of the equation. After I did that, what do you do?
Divide by 2.
Before I do that, what am I going to do? Rewrite, yeah. That's what I'm going to rewrite. And now what do you do to both sides?
4.
Divide, good. And now you get an answer. Now, I know as you go through this one, this is not a difficult algebra problem. A lot of you guys probably knew the answer was going to be x equals 2 just from looking, or x equals 4 just by looking at it, because it's pretty quick. What we do in geometry is that we're going to use properties, bless you, definitions, theorems, things like that to show reasons why we did something. What we do a lot of in here is that we're going to turn this algebra problem into what we call a 2-column proof. Okay? And let me define for you guys what this stuff means, and we're going to go back and forth between these two parts of it. This is what we call a 2-column proof. One side is going to be your statements, and the other side are your reasons. I don't. Bathroom right there. Felt bad. I know he pulled his nose and kind of opened the door to hit him in the nose. Felt bad. Statements. The statements are, what are you doing? And the reasons are why you did it. Hi, Judah! I'm fine. You found my balloon.
Now, I was going to suggest to wake these kids up.
Sit on it.
You need to get a balloon with helium and let them touch one time. They're going to wake up in the classroom.
Yeah. Or I can just sit on it and explode and make them scared.
Oh, that's great.
So one side is what you're doing. The other side is why you did it. When we go through these things, the reason portion is always going to wind up being definitions, theorems, it'll be properties, things like that. It's things that we've defined, it's things that you will see that I give you guys this kind of like a, I don't know, cheater sheet, if you will, to allow you to keep up with the properties, because Lord knows you're not going to remember all the properties. And in essence, do you really need to memorize all the properties that we use?
Nope.
No, you really don't. But can you put a string of thought together that is valid in a correct sequence for an argument? That's what we try to do. That's what we were looking at doing here. So if we go back and look at what we have here, this would have been my statements, and this would have been my reasons. And that would be like the last time I ever write out the word statement and reasons. It's usually just going to be an S and an R. I'm sure you guys will be okay with that. But we need to come up with reasons why we did those steps. And this is why I made up for you guys, well, we actually made this a few years ago, a property sheet. And this property sheet has all these different, what we call reason banks. These reason banks are the reason why you do certain problems, the reasons that you're allowed to use. If it's not on this sheet, you can't make it up. You're so I didn't really I don't know. I know, there's more on the other side. I know there's bears coming around. And what we're going to do with a lot of these things here is that we're going to take them and we're going to use them in such a manner that we're going to make it easy for us to work with. Now, what I want to do today is spend some time talking about these algebraic properties. And I want to show you guys how we use them with these very simple algebra proofs. And instead of writing out these properties, like addition, property, equality, things like that, we abbreviate. And I want you guys to have the correct abbreviations, because if you don't use the right abbreviations, it's wrong. Okay? Do we have enough of them now? All right. So, for example, we're talking about algebraic stuff today. Adding things to both sides equal, subtracting both sides from the equal sign, things like that. What I want you guys to remember is that anytime that you add something to both sides of the equal sign, it stays balanced. You add one to one side, you have to add one to the other, because remember, numbers are jealous. You know, if you have a Cheez-It, why doesn't everybody else get a Cheez-It? Which means put Cheez-Its away. There's not enough Cheez-Its to go around.
Am I supposed to share?
But you're supposed to be eating.
You said what?
Exactly.
I don't know what you just said.
Are you supposed to be eating? Well, you also have earphones in, so.
I don't have any music on.
I know, but I'm just saying. Okay.
Well,
Thank
I
you.
don't know. I mean, some classes let you eat and some don't. I just eat until they say stop.
Oh, there you go. Now, what I want you guys to see here. You okay now? What I want you guys to see here is that the stuff that we're doing really isn't that difficult. But the idea is that the better we get at coming up with the right reasons and putting them in the right order, it's going to make everything easier for the next couple of months. Because I'm not going to lie, proofs can get tough, especially if you don't keep up with them. One of the big things that that I see every year with these things is that people just stop trying and they say, I don't get it, I don't know what to do. That is a completely total BS answer for any of these questions. Because each one of these proofs has the same starting spot. Every single one of these things starts the same. 99.5% of the times, you will be given something to do. I gave you that problem. So the reason you wrote it down is going to be because it was given. And that's what we start with. You start with a given. In an algebra problem, you'll be given an equation to work with. In a geometry proof, you will be given some information. You would start by writing down that information. Algebra is pretty simple. You guys know how to go about your way to solve for x. Geometry, on the other hand, is going to be a little bit more difficult. Before we get into our properties here, I want you just to flip over real quick. I want you to look at the back. On the back and the bottom here, we have all these different definitions. We have bisector, complementary angle, congruent segments, congruent angles, linear pair, midpoint, all that stuff. We have all these different definitions and whatnot that we could be given. What happens in geometry is that you could be given something like this. Given x is the midpoint of AB. You might be given that statement. I'm not worried about what it's asking you to prove quite yet, but if you just remember, what does the definition of a midpoint mean? What does that mean? It's the middle. What's created? Two equal segments. So the idea that happens is that we're going to come up with these what are called progressions. progressions that I use are like little how-to boxes. And I'll say, if given a midpoint. If you're given a midpoint. Well, if we're given a midpoint, we're going to be able to, put your phone away, please. I can watch you watching it. Just put it away.
I don't get my phone out.
I wasn't talking to you.
Oh, I don't know.
All right? So what'll happen is, you'll be given some sort of information. You're gonna have these sheets, and these sheets are gonna become your own. I'm not gonna take these from your quizzes and tests. This is how you're going to be able to know what to do. You have to become resourceful in your own right to be able to look back and reference what we're doing. There is nothing that we're gonna be doing that you won't have all the answers in front of you. You have to understand how to just find them. So we're going to create these boxes next week that will stem from definitions that we know, that we're going to be able to utilize because we'll know how to write things down in a sequence. That's kind of what we're heading towards. Okay? It's a lot of just little definitions and flipping between pages. Okay? So just real fast to finish this out, if I know that I have a midpoint, if I'm given a midpoint, I would state that some segment equals some other segment. Why do segments equal segments? Because of the definition of a midpoint. This is the type of stuff that we'll be able to do. So when you see a proof later on next week that you're given that something's a midpoint, you can't just say, I don't know what to do, because you will have a map of what to do. Okay? It is going to be quite literally, if you write down these things that I'm showing you, it's very difficult to mess it up. So you have to trust the fact that I kind of have an idea of how to make this stuff work for you. So I know a lot of you guys have heard, proofs are awful, proofs are terrible, I hate proofs, all that. The way that I try to set these things up, whether it's the algebra stuff today, a little bit tomorrow, and then the segment and angle stuff next week, you've got to trust me that I know that this method works. Okay? It really does help. So please help it over. All right, anyway. Now, here, what did we do here? We added 1 to both sides of an equal sign. Now, according to our property sheet, whenever you add something to both sides of an equal sign, it stays balanced. So the property in abbreviation-wide would be this. Add, prop, equal. I want you guys on the sheet that I gave you to put down the abbreviations that you are allowed to use. These are the ones that I use, which means these are the ones that you can use. Don't make up your own, okay? Just use what I'm using, you're gonna be fine. Same thing, subtraction property equality. That means you're subtracting anything from both sides. I would write it like this. I don't want to write just sub, I'm going to put sub t. Because subtraction and substitution both start with sub. And that's how I distinguish between the two. Sub t means subtraction. Multiplication, pretty easy. Mult. Division is the only one that I use the symbol for. It's the only one that I use the symbol for. Okay. Distributive property, sending something into the quantity. Remember we multiply in, going in like that? Let's just call it distro. I know there's not an O in distribute, but and the last one is what we call substitution. Substitution is one of these steps that you're going to see so many times in these types of problems. We're going to call it sub. I don't abbreviate it. I just write substitute. And substitute just means you're putting in something for something else. Now, yesterday, we had that, what do you call it? A equals B, B equals C. Then we could say that A equals C, the law of syllogism. And the reason that that worked was, that was on a diagonal. That's actually called the transitive property as well, and that's on your sheet. We'll talk more about that tomorrow. But the other thing I wanted to show you was this. Is that a valid statement? A equals B, C equals B. Therefore, A equals C. Is that a valid statement? Yeah, it's the same thing. This, when they're above one another, that's when we use substitution. This is going to be what we call transitive, because it's diagonal. It's a matter of how things are going to be worded. You're going to see the difference between these two a lot next week when we start writing actual segment stuff out, just how it writes them through. So just want to give you an idea. These are still both valid. It's just how they're written. If they're vertical, we're stacking them. And here, we're just diagonal. Okay? That's one of the other things we'll start to see. So using our properties here and filling in our blanks, if we added on the same side, or added both sides of the equal sign, what was the property we called it? Add prop, and then equal. We didn't talk about this yet. What do we do now? What's that? What did we do here when I went to that step 3? What did we do? We rewrote it. Now, instead of using the term rewrite, we use something different. It's called simplify. And I want you to put this at the bottom of the sheet. At the bottom of the sheet, below where it says transitive and all that, I want you to put the difference between simplify versus solve. Simplify versus solve. The difference between writing simplified and writing solved is, well, simplify is when you rewrite, or when you're combining like terms. And it's generally in the middle of problem. Solve is when you're done. Okay? Solve is only when you're done. When you're done with x equals blank. When you know that you've solved for x. So you're done. That's the only time you use solve. Versus simplified is when you're rewriting, when you are combining like terms. Things of that nature. Generally when you're in the middle of a problem. Now, depending upon the type of algebra problem you have, you might be simplifying multiple times. And that's okay. There's nothing wrong with that. There's really no set number of steps for a lot of these types of problems. What we're working on really today is making sure that we take our time in writing these things out. We're taking our time to make sure that we slow ourselves down, not to overskip a step. Okay? Things like that. We'll go back then. So we simplified. What do we do to both sides here? Yeah. So it'd be division, property, equal. And what are we done with that? Solve. Exactly. Now, a lot of responses throughout the other two classes today that people were seeing, oh, this makes total sense. It's the order in which what you did. Last hour, someone actually asked, why didn't we do this in algebra? I'm like, well, one of the reasons that you don't write out all the rationale for your steps in algebra is so that way you just practice the algebra. The writing of the rationale of it is more of the geometry part because it's starting to get you into this idea that, excuse me, you're starting to use the idea of this, the two-column proof. You only see this in geometry, okay? You only see this in geometry, or you'll see it in upper-level math. I left myself a note to bring in for you guys tomorrow, some of the calculus. We have proof classes in college that all your stuff, the entire thing is all theoretical proof, where all you're doing is proofs. It's awful. I didn't remember it happening. But I saved my stuff. I just had to go find it in my basement. But I'll show you guys some of the old proofs that we used to have to do. It was pretty crazy. Let me show you another one. This didn't work as well as I had hoped. Oops. There we go. The same idea. What goes on the left? And then? Why are you writing that down? Why are you writing down 2x plus 5 equals 20 minus 3x?
It was given.
It's given. This is given. It was given. It was my gift. Merry Christmas. Well, I'll send you a gift receipt. Welcome. So, what do you do? What do you do first? Does it matter what you do first? If it were me, I would try to move my variables first. But do you need to move your variables first? No. There's really no reason why you can't start one way versus another. I always fall back to what I was taught to solve a two-step equation or a three-step equation. I start by taking on a little guy. What am I going to move? A 2x or a negative 3x? How do you move a negative 3x? Add. So my second step after writing down the given is to add the same thing to both sides of an equal sign. When you add something to both sides of the equal sign, what is it called? Add off equal. You're literally writing down what you did. Okay? I added the same thing to both sides of an equal sign. Add pop equal. Now what? Simplify. Very good. 2x and 3x is 5x, plus 5 is 20. To simplify. Now what? Subtracting 5, so what's the property? I subtracted the same thing on both sides. What is that going to be called? Not sub t. Very good. I kept the same thing on both sides. Gee, what do you have to do now? Not solve. I'm simplifying again. And it is completely fine to have multiple simplifies. Now what? What is it? Okay. This is forcing you to write out all your steps. And then what are you left with? 4. I'm like, you said 4, really? And you're solved. That's what these are going to look like for today. It's going to be multi-step algebra problems. that you're writing down the steps in which you solve them. There's gonna be more than one way to set these things up. There's gonna be more than one way to solve them. It's totally up to you and how you get to X, just like it always has been. But what your job is that you have to keep it straight. You gotta write down what you do. You cannot just skip over steps. Okay? That's the whole point. Because when you get into geometry proofs, you can't skip steps. Because if you start skipping steps, that just means you're making stuff up. And if you're making stuff up, you're gonna be wrong. So that was a good way of, if you make stuff up, hey, look at that. Okay, do this one. Do this one on your own. I'll even give you the first step. You're welcome. Seriously, try that one on your own. Take a couple minutes. All right, let's see how you did. So, obviously, your first step is good because you were given a problem to do. Did any of you guys divide by -4 first?
No.
Okay, you could, because that's just multiplying. It's okay to do that. Most of you guys probably did this. You distributed it in, and you rewrote it as -44x minus 8 is 80. That is your distributive property. Distro property. Now, remember, the distributive property does not have an equals on it. So hopefully you didn't put an equals, because you're not doing it to both sides. So remember, distributive property is on one side, it's just distributive property. There's no equal thing, okay? Next step, I bet most of you guys did this. You added 8. You added 8 to both sides of the equation. Yes, ma'am?
Like between 1 and 2,
Uh-huh.
could we do it where we like you know where you put the distributed property? I gotta simplify it before that.
Did you write something different to here? Did you write like -4 times 11? And then, what'd you write? Let me just see. And that's, distributed property is a little weird. There's a lot of. That's fine. I have no problem with that. Absolutely not at all. That's perfectly fine. What she did, guys, is she did this. She wrote it as -4 times the 11x minus 4 times the 2 is 80. And then here was a simplify. And went on from there. Perfectly fine.
That's what I would.
Either way is okay. I'm fine with either one, okay? I'm absolutely fine with either one. This is actually the first time that I've done these problems that I did not write out that step, because most people skip it anyway. So that's fine. Okay, it's no worries. And like I said, you don't have to have the exact same number of steps or in the same sequence. As long as your logic of the reasons that you're using makes sense, you're fine. Okay? So here we have the add prop equal. After that, hopefully you guys did a simplify step. After that, I'm assuming most of you guys would have divided by on both sides. So far, so good? And then you should be done. That's what we're starting with today, guys. That's what we're starting to work these things through with. We're going through small chunks of algebra problems in order to solve, to show the steps, in order to write out properties. Don't make up your own abbreviations. Don't make up your own statements, or excuse me, your reasons. Use the abbreviations that I use. That's what's legal. Everything else is wrong. Okay? It's kind of the easy way to think about it. Let's do one more, then I'll give you your props.
Is it on the worksheet today?
Yeah.
Oh, okay. I didn't see it on the website, that's why.
Oh, it's on there.
I just seen like a link. Is that what it?
I think I just linked to the page in the book. That's about it.
Oh, yeah.
That's
maybe
all
I
it is.
didn't. I didn't go to it, so.
I'm not giving you your first step this time. You'll have to figure it out on your own.
Oh, it's so difficult.
Seriously, you guys ever get that one wrong, I'll be very sad.
Always be simple. 7
Secondly, what did you move first?
3x.
Now, did you add or subtract 3x? Good. So you add 3x to both sides. What's your reason for adding to both sides?
Equal.
Add pop equal. Thank you. And then simplify. Good. Now what'd you do? Subtract the 9. Sub t prop equals. Good, good. Now what? Another simplify. Okay. After that, what'd you do? Okay. When you do that, you wind up with divide prop equal. And last but not least, x is? And you are? Done. Okay. Now, notice we've had ones that were, 5 steps, this one was 7. Then the algebra isn't difficult. I just want you guys to practice writing out the actual steps. What are the reasons that you're doing them? Okay. The homework itself is already placed on the calendar. You go here. You might have been looking at the Algebra 2 stuff. That had a hyperlink to it. Do these, please. This is in section 2.5. All right, there's 5 of them. I have 5 of these problems for you guys to do. Don't make stuff up. All right?
That was like
Making stuff up?
yeah, assume like
Don't.
that looks like a 90-degree.
You can't assume. You make an angle side out of you and me. No assuming. Max, would you get the door, please? You then.